seems like it's been running slowly.
Alright, we're looking at lesson 65 today. We're looking at radicals in trig equations, and then we're going to look at graphs of log functions. Alright, so we're looking at a trig equation, but now it has a radical in it. I'm not going back. Y'all should have been writing instead of talking. So what do you do with radicals whenever you have them in an equation? Yeah, you want to get rid of them by squaring them, but we don't want to square it right now. You want to single it out, okay? So if we move the radical over, have we isolated our radical? And now what do you do with your radicals? So if you square both sides, what do we have on the left side? Sine squared x equals 1 minus sine squared x. Now what? Put them together, and you have 2 sine squared x. Now what? Okay, so sine squared equals 1/2. Okay. So what would sine x equal? Plus or minus the square root of 2 over 2, or if you wanted to leave it as 1 over the square root of 2, either one works. What does x equal? $45? 135, okay. That's if it's a positive 1 over square root of 2. What if it was a negative? 225? Yeah, 315 Ben. That's all of them. Yeah, because of the plus or minus. Yes. The positive 2 are the 45 and the 135, and the negative 2 are the 225 and the 315. Same answers as what we've gotten before, just a different way to get there. Okay, let's look at another one. This one is actually a little bit easier. It may not look like it right now, but it is actually a little bit easier. Any ideas? You do not want to FOIL. That would be a bad thing. Yes, tangent of x equals the square root of 3, and yes, the sine of x equals negative 1. You set both of your factors equal to 0. Do you see how, after one step, we're already to that part? We'd have to go to like 8 different steps to get there. Okay, so when does tangent equal square root of 3? Why 240? In the third quadrant is where tangent's positive. Okay? What about when sine is equal to negative 1? 270? Okay? Remember, Ben, you should be doing these without your calculator. You should know these in your head. You shouldn't have to use your calculator for these. Okay? So, this one is a little bit different than the last one because look here. It's in radians. So how do we change it into radians? Which is it? You're going to multiply all of them by pi over 180. So what is 60 divided by 180? Okay, so 1/3 pi, or pi divided by 3. What is 240 divided by 180? Yeah, 4/3 pi, or 4 pi over 3. Either one work. What about 270 divided by 180? Yep, so 3 over 2, 3 pi over 2. And those are your answers. Any questions on this type of trig problem? All right then. Now we're going to graph a log. So, any ideas how to graph it? Yeah, plug in some numbers, but can we plug in numbers into log base 3.5 of 5? Do we know how to figure that out? So what do we need to do before we plug in numbers? Change it into exponential. Yeah, well, we want to change it before we start plugging in numbers. So what would it be in exponential? 3.5 to the y equals x. Yeah. So now what numbers are we going to be plugging in? For x or for y? Y for y. It makes sense, right? Okay, so what numbers do you want to plug in for y? 0, 1. I don't want to do 2. You plug in 2. It's not going to fit on my graph. Yeah, it won't fit on your graph. What is it to the 0? It's approximately 0.29. Now, if you want to do what Ben said and plug in 2, you can. But you get something that won't fit on our graph, and you don't need to waste time graphing that big number. So, how do we graph it? Okay. Okay. Maybe. And now you graph it. It is exactly an exponential curve. It's just tilted. Like it is an exponential curve because this is an exponential equation. It's just tilted. So that's how you graph those. Any questions there? Okay, I didn't see any to omit on your homework, but that's your lesson for today. Now we get to do your test corrections.